Good evening, guys. It's Kene once again. All right, so today I want to talk about Lambda functions in Python. Right, so I'm going to dive right into it by sharing my screen. And guys, I have some of the things here. I have the things I'm going to be talking about, Lambda function. What is a Lambda function? What's the syntax of a Lambda function? And then I will just give some examples of Lambda function. Right, just look at the things that I will be talking about today on the screen. Right. So let me just get right into it. What is a Lambda function? Just to attempt a definition of a Lambda function, I would say that it is an anonymous function. A function is meant to do a specific thing, right? And it is just like a block of code that you write once and you can use multiple times for the same thing, like you need the same result. So you write the block of code once and you execute multiple times. That's a function. But the thing is, a Lambda function is anonymous in the sense that it doesn't have an identifier like a regular function would. And again, it can take 0 or more arguments. So it could be 0, no argument, or 1 or 2 or 3, or even, any number of arguments, but there can only be one expression for a Lambda function, unlike a regular function, okay? All right, so that's what I would call a Lambda function. You begin a Lambda function with the keyword Lambda. Right, so that's it, guys, about the definition. So let's look at the syntax of a Lambda function. What is it like? We've said that it could have any number of parameters, but can have only one expression. Let's see. So I begin with the keyword Lambda, and the parameters will not be enclosed in parentheses, unlike a regular function. So I'm just going to say, okay, this function should have two parameters, A and B, set apart with a comma. You see that I haven't used parentheses, to enclose the parameters there. And after the parameters, there should be a colon and the expression. So that's the syntax basically of a Lambda function. That's how you would write a Lambda function. Now, if I choose not to have any parameters, you have the colon right after the keyword Lambda. Okay, so that's it, guys. Now, let's look at some examples. Having talked about what a Lambda function is and given the syntax of a Lambda function, we now have to examine some examples of a Lambda function. Right, so I will create a Lambda function here using the keyword Lambda and have two parameters, yes, A and B. And all I need to do is return A plus B. So you see here that I haven't explicitly used the keyword return because that's already part of a Lambda function, the return quality there, right? So that's the thing about a Lambda function. You don't necessarily have to, you don't have to use the keyword return. Okay, so guys, I'm going to store this in a variable I'll call my variable or my Lambda. My Lambda. Okay, so next I will do is just simply show, just call the Lambda, my Lambda, which is now stored in this variable, my Lambda. Then provide the arguments as required, 2 and 3. So when calling the function, you must, in this instance, put the parameters, enclosed. You need to put the parameters in parentheses. Okay, so let's see, guys, what that gives us. I see that there is 5. That's one example of a lambda function. What about a lambda function with no arguments? Let's see. My lambda 2, and this time no arguments, so a colon just follows, and I need to print something. I just maybe want to say hello world, so I'll put it there. Hello, just print. I need this to print something. Print. So that goes straight to the expression hello world. Okay, so that's it, guys. And if I run, or call the function rather, with no arguments, we'll see what that gives us, guys. Hello world. So those are two examples of lambda functions. All right, so the next, guys, what are the differences between a lambda function and a regular function? I have talked about some of them before now. I said that a lambda function begins with the keyword lambda, whereas a regular function begins with the keyword def, D-E-F. That's one. To return a value, you need to use the keyword return in a regular function, but you don't have to use the keyword return in a lambda function because returning a value is an essential attribute of a lambda function. Okay, and for a regular function, you could have, several expressions, right? But for a lambda function, there can only be just one expression. Let's look at some examples. And of course, for similarities, guys, we know that there are functions, regular functions, lambda functions. In other words, they are both callable. You can call the two of them. After all, they are functions, aren't they? Okay, so guys, let's make the comparison using examples there. So I'm going to create a regular function that would take a number, get the square of the number, and return that the squared value. Okay, so I would say my squared, whatever it is, my squared, that takes one argument, and I'm simply going to return. So one argument should be, say, a, return a raised to the power of 2. That's all I need to do here. And then I'll call my squared. I'll call my squared, provide parameter, or the argument rather in this case. So the specific value is the argument. Okay, so let's see, guys, what that gives us. My squared, 25. That's a regular function. You see that I've used the keyword def, arguments in parentheses, and I've used the keyword return. Okay, now let's look at the lambda function again. Lambda, my squared. Oh, sorry. I thought I was creating a regular function. So no identifier, no name for that. So I'm just going to have the parameter followed by a colon. And on the same line, guys, it has to be on the same line if it's a lambda function. The expression has to be on the same line. Okay, so now I'm going to just simply do A, or rather, sorry guys, this should be B, I meant. 5. Let me just create a space here. So lambda B, and simply do B raised to the power of 2. Okay, so you see that there is no return statement, yet it's going to return a value. So what I will do now is first store this in a variable, my var, store the lambda in this variable. So the variable now actually is a function which can be called. So my var and give an argument there, and let's see what that gives us. 64. So we get the difference, guys. It's anonymous. A lambda function is anonymous, so that's why we should, store it in a variable which we can now call like a regular function. All right. Now, what is this IIFE? It simply means immediately invoked function expression. If you look at the lambda function I created here, I had to store it in this variable and then called the function, which is the variable there, right? So I called this function here. Can I create a lambda function and execute it, call it right after creation without doing the calling at some other point in our program? So that's what we should understand as immediately invoked function expression. And how do we do that? Just wrap the lambda function in parentheses and another set, another pair for the parameters. Let me just give us an example. So I'm going to create a lambda, and this time I'll call it added. Okay, so let me just have this as added, right? Oh, sorry, I keep forgetting. I'm not supposed to, I keep thinking that I'm creating a regular function. So, but that's not the case. So I'm just going to have my parameters there, okay? Then colon A plus B. Okay, so that's the lambda. Normally, I should store the lambda in a variable and then call that lambda that is stored in the variable. But this time, I'm going to call the lambda right after creating it. So I'll wrap the entire function in parentheses and now include the arguments in yet another pair, okay, of parentheses. So that should be 3 and say 6, okay, just like that. And once I run, you see the output immediately. So I didn't define and on some other line call the function. I did the defining and the calling all at once. So that's what we mean by immediately invoked function expression. Now, should the lambda function not have parameters, how do I immediately invoke such a function? So in this case, no parameters, just need to print something, no parameters, no parameters, right? And you must include empty parentheses, yes, because you are calling the function. And after that, I'll just run the program and we see no parameters. So that's it, guys, about the IIFE. Now, what about using lambda functions with if-else scope, like an if-else with if-else block, so to say? How do I use the two together? Let's see, guys. Now, what I want to do is have a program that will look at a number and say, okay, so this number, if it's 10, the output should be your number is 10. And if it's less than 10, the output should be less than 10, as in words. And then if it's greater than 10, the output should be greater than 10. That's one. But okay, let me take a simpler one. Just a program that would check whether a number is even. So I'm going to use a lambda with the if-else block. Okay, so let's see, guys. Lambda takes one parameter, and then I'm just going to check Is it even? Using the modulus operator, a modulus 2, if that gives a remainder of 0, then what should happen? If, sorry guys, this is just going to be print even. In this case, print even. Now this is going to be the output given this parameter if, when I divide the a by 2, there is a remainder of 0. So guys, let's understand it. Output this given this parameter if that parameter divided by 2 gives a remainder of 0. And I must include the else part of the block. Okay, so if it's not so, then what should happen? Just print odd. That's it basically. Okay, I hope we get it, guys. Print odd. Right. And I'm going to store this in a variable called my func. Just my func will just be okay. Okay, so guys, let's see. I'll call my func. And give a single parameter, maybe an argument of 8, and we'll see the output. So you see that it is even. And if I try to make this odd, I see that the result is different. So that's just for if else. Now guys, I was saying just before, I decided to give this example, I said that it's also possible, even though it's not permitted, like to use the elif segment of the block in using the if else block with lambda. So it's not possible to use elif, but there's a workaround. You can have the else if part in the else part of the if else block. Okay, enough of the talk. Let me just give an example. So this is what I want to do. There'll be a number, say 10. Now the program will check if the given number is 10, and if it is 10, it would simply say your number is 10, equal to 10. If it is less than 10, it should output less than 10. And if it is greater than 10, then it should output greater than 10. So how do I write such a program? I'm going to make use of lambda with if else block. So let me go right into it. Lambda, just one parameter. Okay, now what should be the output if the condition is true? I need to check first. Now, if the number is less than 10, if it's less than 10, show output less than 10. So this should be the output. Let me just use the symbol there. Less than 10, right? Okay, so what's going to be that condition if? So let me just call this print less than 10. Sorry guys, it's going to be less than 10 if the given parameter is actually less than 10. Now what should happen if it's not less than 10? So we have two more things to consider. Now, if it's not less than 10, that means it could either be 10 or greater than 10. So I want to check now if it's exactly 10. Else, print equal to 10, right? If, so I'm going to give the condition. If the given number is actually equal to 10, right? Now, what if it is not equal to 10? So it's neither less than 10 nor equal to 10. So it must be greater than 10. So that will require the else block. Else, what should happen? Just print greater than 10. So that's it, guys. Just like that. I'm going to store this lambda in a variable I would call my func2. My func2. Okay, so please, guys, don't mind my naming style there. And I'm going to call my func2, provide an argument, let's say 3. Let's see what the outcome will be. The output will be odd, right? So it's odd. It is this part that gets printed. Oh, sorry. This is for this. I'm going to my func. Okay, here. So this is going to be less than 10. This part gets printed because 3 is less than 10. What if I make this 10 and I run the program? I see that this part gets printed. And if I decide to use something greater than 10, say 16, I see that the function returns, no, enter. Can be my func2. Oh, sorry guys, my error. This should be greater than 10. Okay, so if I run again, I see that it is greater than 10. Okay, so guys, that's how you use the if else and lambda function. The next, guys, is using the lambda function with higher order functions. Okay, and what are these functions that require functions as parameters? They are higher order functions. Functions such as filter, map, and reduce. So we're going to use these three, as examples in discussing how a lambda function can be a parameter for another function. Okay, so let me start with the filter. The filter is a method, so it should have parentheses, right? And I need to create my list first. Like, I want to use elements stored in some sort of container. So example of such a container, I can say a list, right? So I'm going to say 1, 2, 3, 4. Just store these numbers in this list here. And the filter will take two parameters there. The first parameter is the function that will actually compute something. And the second parameter is the container holding the values we would use in the lambda function. Okay, so I would say lambda. The filter is this, guys. Just before I go on, it looks at a subset of a set, like a subgroup of a supergroup. So the filtering will be based on a certain condition or conditions normally, but I'm using lambda here. So it's going to be based on a certain condition. And for instance, I could say, oh, I need all numbers greater than 5, so 6 up. That's what I want to do. I'm going to filter out all the numbers that are less than 6. So how do I do that? Lambda It's going to take one parameter. Now, guys, this parameter represents each of these elements here, each of these numbers in this list. So the value of the parameter is actually dynamic as it goes through all these elements. It assumes the value of each of these elements. Okay, so lambda A, what's going to happen? Just pick that number if it is greater than 5. In other words, A greater than 5. Yes, so if this is true, if A, that number is greater than 5, just keep it, because that will form that will be part of what will be returned, when we execute the filter method. Right, so that's it. I'm going to include my list as the second parameter. And that's all you need to do, guys. So I'm going to store this in a new variable, my filtered. And please, guys, the filter method returns a filter object. But of course, it's not going to make sense, practical sense, to have an object with some, incomprehensible stuff. So I need to convert the filter object to a list by using the list constructor. And it's just as easy as using list, and the parameter will be everything that I need to convert to a list. Okay, so in this case, it is the filter object. Now let's see, guys, what we have, my filtered, and then simply call this function. Sorry, it's not a function, it's a list. Remember, I've actually now converted it to a list. So my filtered, and we'll see what it gives us: 6, 7, 8, 9, 10. So that's it, guys. That's how you use the filter. You can use the filter method for lots of stuff actually. So this is just one example. Now, because of time, I will just go straight to the map. What about the map? The map method. It's used when we need to carry out transformation on every element of a list or a bucket. So you have things inside a bucket, and for each of the items inside, you need to carry out some transformation. So you need the map. In this case, let's say I have this list, and I want for each of them, for every element, there should be multiplication by 2. So it will take 1, multiply by 2, take 2, multiply by 2, take 3, multiply 3 by 2, on and on until the very last element. So how do I use the lambda? So guys, let's see. My mapped. Okay, and I start with map. It's a method, so remember, just put the parentheses. Then next will be the lambda, the first parameter there, lambda, and that will take a parameter. And now what is the transformation that should take place? That simply is a multiplied by 2. So a multiplied by 2, that's the transformation. So the next will be the other parameter, which is the list I'm going to, pick the items from. And that's all, guys. Remember, again, that there's an object here. And in this case, it's the map object. It's a map object, which I now need to convert to a list using the list constructor. Right. So list here, and like this. That's all. And when I run my mapped, when I execute my mapped, I will see the output. So guys, check. 1 multiplied by 2, 2, 4, 6, 8. So you see that all the elements have undergone multiplication transformation. Right. So that's how to use the lambda with map. Now let's look at reduce, the reduce method. What is it for? Okay, now given this list of numbers, I want to add all the numbers to get a single value, a single integer value in this case. So I'll start with the first and the second, add the two, and the sum is stored. The third or next number is added to that sum to get a new sum. The next number after that is added to the previous sum to get a new sum, so it's like cumulative. It keeps adding one number to the sum of the first two, or the two before that particular number, okay, until all the numbers have been added. So it's just something like 1 plus 2, and when that's done, I would add 3. When that is done, I will add 4, right? When that is done, I'll add 5, on and on and on, like that. Okay, so how do I do that? Remember, I'm starting off with 2 parameters, the first 2 numbers, and I can add the rest of the numbers. So guys, let's see. My sum will be reduce. Now it's a method. It's going to take 2 parameters. First will be the lambda function, which will have 2 parameters. So lambda A and B. Then what am I going to do with the A and B? Add them together to get a sum. Then the number after, to the right is added to that sum to get a new sum, and the number to the right is again added to that sum to get a new sum, and that's how it progresses to the end. So the next now will be to provide our list. Okay, so that's it, guys. What the reduce method returns is, in this case, a number, because I've asked it to sum up all these values to get a single number, an integer number. So there's no need. I'm not creating a list. So that's why I'm not going to use the list constructor here. It's just going to be an integer. All right, guys. So let's see. Before I use this reduce method, guys, I need to mention that the reduce as of Python 3 is no longer part of core Python. It's rather included in the functools module. A module is a file that has functions that can be imported into your current file to execute or to accomplish something. Okay, so I'm going to import, just use import reduce, sorry, from functools import reduce. That's it. So from this module, I'm going to import this method here, reduce. Okay, so guys, next I'm going to do is just output the variable my sum. That gives us 55. All right, so that's it, guys. You add all these numbers and you get 55. These are basic examples you want to explore, right? Just go online and just look at other examples that you might find on the internet. keep practicing until you are perfect. Okay, so that's it, guys, about using lambda function with higher order functions. Let's look at using lambda in list comprehension. I'll give an example. What do I want to do now? I want to use a for loop within the list comprehension and loop through a range of numbers. Now, for every item in that range, I'm simply going to multiply it by 2. That's all I want to do. And then output the list. So I'll start lambda x multiplied by 2. That's it. And then I'm going to give the loop for x in range. So I won't go from 1 to 10. So inclusive start range 1, exclusive 11, so that the 11 is not included. So it stops at 10. Range 1 to 11. Now, guys, watch. I'm going to create different functions. A different function for every iteration. So first iteration, a function is created. Second iteration, a function is created until I have got to the last iteration there, to the end of the loop, which is at 10. Okay, so I have simply created a list of lambdas, a list of lambdas here, guys, in this list comprehension. Okay, now I'm going to save this, my list of lambs, my list of lambdas, just something like that. I'm going to show us, guys, just by, let me just output my list of lambs and see the results. So you see, these are all the lambda functions contained in this list here, in this list. Now, none of the lambda function has been called. No, I haven't called the lambda function. And I'm going to discuss something, more, but I'm just going to mention it here. Lambda, there's something called late binding. Now, you might assume, guys, that the x here is a value at a particular iteration. So first iteration, that this x is 1, and second iteration, the x is 2. That would be the assumption. But would that be right? Let's see for ourselves, guys. So I'm going to, again, create a list, this time for f, which is the lambda function, for f, rather, in my list of lambs. So it goes through all the lambdas in this list. And then for each of them, I'm simply going to execute or call that function. That's all in this list comprehension. And I'll just print everything, guys. I don't want to create another variable, just print everything and we'll see what that gives us. So what do you think? Every number in the range of 1 to 10, multiply each of them by 2. So I'm supposed to have 2, 4, 6, but let's see what that gives us now, guys. 20, 20, 20, 20, 20, 20. Isn't that strange? Like, why is this so? I'm going to talk about it in the next example, talking about late binding in lambda functions, guys. Late binding in lambda function. But just to correct this here at this point, I am simply going to have that value in this range that is set. So I'm going to come back to this just when I explain late binding. That is set as of the creation of the lambda function. So it is captured right away in the lambda, right? So if I set a value for that parameter, then a unique value for x is captured here. If I run, I will see the result. So we see this time it is 2, 4, 6, blah, 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 blah. Now let's understand what late binding is. Lambda functions have this feature, like this late binding feature, and it's just simply binding a variable to the function at call time. So the thing is that the system doesn't look for the value of a parameter when it is defined. No, it instead looks up the value of a parameter only when it is called, when that function is called. And remember that lambda is a function. So it just creates 10 times, it creates lambda functions, right? Creates a lambda function for every iteration. But it doesn't assign, okay, at this point here now, it doesn't assign a value for x yet until we have looped through all these numbers, right? It just knows that there's going to be an x, and the value of x already exists. I mean, x already exists in memory, but the value of the x in the loop keeps changing. And remember that the lambda function has no need for the value of the x yet. So it actually looks up the value only when I call, and the calling takes place here, at which point we have already, or the system has already completed the looping. So that's when it starts looking for the value of x. And you know that the value of x is the last one after the looping, and that's the 10. So the last value of x is 10, and that is what it actually finds when it is called. It looks for the value of x in the surrounding scope, and the surrounding scope here is this loop. In the surrounding scope, and that value of x is the last value of x from the loop, which is 10. And so it's just going to take that 10 and multiply it by 2, 10 times. So let's see that again here, guys. So that's why we have 20, 20, 20. So it's this late binding thing in Python, that some people may find quite confusing. Okay? So remember, a function, the value of the parameter is not looked up until the function is called. And when it is called, it looks for the value of that parameter in the surrounding scope. It finds that value and uses it. Okay, so now let's again explain late binding with yet another example. Now I'm going to create a function, a regular function that will, okay, now let's do it this way, guys. Let me explain lambda functions as closures. That will make it clearer. Now think of a closure as an inner function that has access to variables in the surrounding scope, not within it. So the variable does not lie within that inner function, but instead lies in the scope of in the surrounding scope. So if I define a function in a super function, then that subfunction can access variables in the super function where it is defined. So that's what you call closure. That inner function serves as closure. It closes over the outer function. So let's understand what a closure is and see how a lambda, constitutes a closure, how a lambda function constitutes closure, right? I'm going to define a function def outer function, which I'm just going to call ofunc, and then create a variable here in the outer function, this outer function, and just call it 4, right? Assign it a value of 4. Then I'm going to define a lambda and say take one parameter b, then have a be added to b. That's all I want. Then the next thing is to simply return this lambda. So I'm just going to say, let me call this L. Okay, no need. No need for the return. I'll just leave it at this point, just like this. Right. I think it's okay there. So this outer function contains a lambda function as an inner function. Now, the whole concept of closure is that this inner function lambda has access to a function defined in the surrounding scope. In this case, this variable is created in this outer function, and then you see that this lambda is created too in the scope of this outer function. So both are created within the scope of the outer function. And so even after outer function has been executed, this inner function miraculously still has access to this variable, even after this function has completely been executed, right? So let's see, guys, if that's possible. So my var, call the outer function ofunc, we see that what is returned is, sorry guys, let me just have the return here. What is returned is this function, just this one here. Okay, so let's just see it. So we see that it is a lambda function that is returned. Now, the next thing now, guys, is that we need to execute or call this inner function, this lambda here. You can see that it's a lambda. My var is a lambda function. So I want to execute it and see, I've already executed this inner function, right? But I still want to see for myself if calling this inner function, whether this function still has access to this variable here. So let's see, guys. And I'm going to say 7 this time. And voila, 11. I mean, the outer function got executed. The execution was complete. And then I call the inner function. So how is it that it still has access to this variable here? Yes, guys, that's what you call closure. And a lambda function is basically a closure. It closes over the outer function. It closes over. So this lambda function here closes over this outer function. All right. So thank you, guys. Now, let me now come back to the issue of late binding. I'm going to define a function, and see if the inner function, which is a lambda function, has access to different values of a variable within the scope of that outer function. So let me say def my outer function. Let's get this down. My outer function, and I'm going to use a loop here, guys, for I in range. So I'm going to say 1 to 10. Okay, so I'm going to create a list to hold the lambdas that will be created in each iteration. So just say my list. So that will be list of lambdas. So for every value of I, for every I, I'm going to create a lambda. Lambda I, this time, let's say multiplied by 3. Okay, so that's it. So my outer function gets executed. That means that the for loop will also run once I call this outer function, okay? Right, so lambda is created to take this I, for use within its scope, within its body rather. So next is simply return that lambda. So the lambda gets created and I'll simply return the lambda created at that iteration, at that point. Then I'm going to next append that lambda to, so my list dot, sorry, my list dot append. So now guys, what I want to do now is, in this case, call, sorry, just append not here. Just append the lambda. So that's what I want to do. Append lambda I multiplied by 3. So this I is used in this lambda and I multiplied by 3. Then that lambda is stored in my list. So I'm creating a list of lambdas. The next I want to do is just return the list. Return the list. Okay, so let's see, guys. Call my function mf, which is going to be mo func. That's all. Now let's see what mf is. It's just a list of all these lambdas created here, just like we had in the list comprehension. Okay, let's see. So I need to get this off. Yeah, so I'm just going to execute my program. We see that there is a list of lambdas. Okay, so I have these lambdas stored in a list. Now, guys, the next I want to do is to execute or call each of the lambdas in the list. So for that, I'm going to create a list for, so I'm going to loop through this list of lambdas for f in mf. just like that for f in mf. So what should happen for f in mf, where f is a a dynamic value obtained from going through the lambdas in mf. So it's a function that I need to call. That's just it. So let me print and we'll see what that gives us. 27, 27, 27. So why is it 27? Okay, this should be 11. So imagine this, guys. This is not what I'm expecting. I was expecting 1 times 3. So 3, 6, 9, up to 30. So, but why do I have 30, 30? It's this same late binding feature. Now, the thing is, guys, when I called this outer function, it gets executed. That's the execution includes the loop. And now I didn't execute the lambda. So every lambda there wasn't executed when I called the outer function. It just defined, it just created the lambda. But the value, guys, that's the tick. The value of I was not set. It just tells us that there is an I as variable and it references an I that is already available in memory. Remember that the loop runs before the value of this parameter, the value of this I is determined. The loop runs before the value of I is determined. So the value of I is not determined until I call that lambda here, by which time this loop has already completed, right? So the last value of I obtained from the loop, in this case, is 10. That is what it is going to use as parameter for all, as the argument for all the lambdas when they are called. So that's why I have 30, 30, 30, 30, 30, So that's a problem. In this case, how can we solve it? What we need to look at here, guys, is to capture every unique value of I right after an iteration. So as I get to a value of I, say 1, I need to capture it. That variable needs to be captured. And we can do that by making that variable, that value in that case, a parameter for an inner function before the lambda, so that we can execute that inner function, providing a unique value for our lambda function. Let's look at an example, guys. So I'm still going to take this and just let me comment this out. I don't know why it keeps giving me these 3 and I don't really need that. Just go off and here. Just go off. Okay. So now, guys, next I want to do is capture a unique value of I for every iteration. I'm going to create an inner function. Okay, so let's see, guys, after the loop, so that the value of I, that unique value of I, which may be 1, 2, 3, 4, is captured as a parameter for the inner function that I'm going to create. So call it def my in, which is mi and func. my inner function, it's going to grab the I, right? Now, this I is a parameter. When I call my func, this inner mi func, it will take this unique value of I as its parameter, as its argument, and supply it to the lambda. So the lambda gets a different value of I, not just a variable that is stored to be used much later, or to be looked up, whose value is to be looked up much later. Okay, so with that done, I will next, before I append this, I'm going to simply return the lambda, right? So when this inner function gets called, it's simply just going to create and return a lambda function. So I'm just going to I want to call that inner function my func, and provide the unique value of I, right? So this I is actually a value obtained from this iteration. Okay, right. So once that is called, I will just simply append it to my bucket, which is this list here, my list. Sorry. Okay, so that's it, guys. So remember, I need to capture every unique value of I that serves as the parameter for this inner function, so that when I call this lambda function, it already has a different I. So the I's are not the same. They are actually separate. That means having separate values. So I'm going to next just return my list, and then we'll see, guys, what the output will be. My var, and call my func, right? So in the list, I'm going to simply say, so just loop through, this inner function is called. What is returned is simply a lambda. So for f in my var, just call that lambda. That's all we need to do. And we'll see the result. Print what I have there. Oh, sorry, guys. It says invalid syntax, line 15. Okay, this should be return, not return. Return. Okay. So we see 3, 6, 9. That is what we actually want, not this. Okay. I'll just comment this out and let's see. You see the difference? For this, the value of I is static. The loop runs before the inner function is called. And once the inner function is called, it is only then it looks for the value of this I. And this I happens to be the last value of I after the loop. So that's late binding. The variable gets bound to the function only when it is, the value of a variable gets to be determined only when that function is called. That's late binding, and you find that if you're not careful to cause some serious bugs in your code. So you need to be careful about it. Right, guys. So I have taken your time today. I hope you learned something. I just thought I should talk about Lambda functions. Thank you so much. I'll be coming to you again with math functions, right, in Python. So have a great day. I'll see you in the next lesson. Bye.